Hey, this is Charan from ACTMEP training program. Today we are going to discuss about software heat load calculation. In this, we are going to learn about introduction to the HAP software, creating weather reports. So how to create the weather report based on the climatic conditions, space creation in HAP. So for each and every space we have to create a space creations. So how we have to create the space creations, duplicate the spaces. Once you create the space, how we have to duplicate the spaces, editing the spaces, and zone creations. Okay, so in this video we are going to learn completely the software heat load calculation. By using software, how we are going to get the results and what are the documents we are going to get it. So the completely today we are going to learn in this video. So before we are starting, let me give a small introduction about this software heat load calculation. To do this software heat load calculation, we are using a software called HAP, that is hourly analysis program. So the HAP full form is hourly analysis program. We are using the version called 4.9 version. So in this software, so the main advantage is you are going to get the accurate results as well as you will get a documents also. And mainly here if you go through this in the 4.9 version, so this is developed by Carrier Software. Okay, the Carrier company people, they developed this software, and here mainly we are going to learn about the entire software load calculation. See here, when I open this one, so what are the previous projects we have? So we have a previous projects over here. If you want to start any new project, so here we have an option called new. Go and select a new. So you will get a pop-up that is called performance pop-up. In this performance pop-up, the first they are asking here ventilation standards, energy standards, lead and currency units. So if you go to the ventilation standards, in the module number 1 we discussed, so what are the standards we are following. Okay, so in this we did, if you remember, we told a one standard, that is 62.1. so this is for ventilation standard. If you have a drop down here, if you see the different years will be there, the 62.1, 2001, 2004, 2007 and 2010. So why they are giving these many years means, if it is a new construction building, then which is the advanced level updated values will be there, so that is we consider. But when you are going to design for the old buildings, like which is a 10 years back building or 20 years back building, then according to the year of construction building, we are going to select the building, which year they constructed. Based on that we are going to consider this one. For example, if the building is constructed in 2005, then we have to go with the 2004. If the building is constructed in 2009, then we have to go with the 2007 standards. If the building is constructed in like 2020 or 2021, then which is the updated values will be there, so that is we have to take it. So here we have a ASHRAE standard 62.1 2010, so I am considering this one. And the energy standards also we have to consider the same, and the lead we are not going to change it. So here we are going to, as per the default, we consider the lead. And the currency they given the dollars, because this is we are following the American standards, right? And the currency also the American only. If you want any euros and German, then you can take it the other thing. Since we are following the standards of American, so we are going to take it as in a dollars. And coming to here, we have one more option called general. Under the general, the measurement units. So what are the results on which measurement you want, whether you want in SI metric or English unit. If you take a SI unit, so this simply one unit I can explain for you. Let it be considered the air quantity. Normally the air quantity we are calculating in CFM, cubic feet per minute. But if you're taking a SI metric, then you are getting a LPS, liters per second. So we are following the SI units. So normally these SI units, mostly in the Gulf, they are going to follow this SI metrics, but the other countries they are going to go with the 90% with the English. And if you want to provide any software, you can provide the email ID. This email ID we can provide it over here, and here they are giving it in a show date and show time. So in the resulting sheets, if you don't want to print it the time and date, then you can turn off this one. If you want to print it, so just keep it as in a check, this both. If it is in a check-in, so definitely when you are going to print the resulting sheets, in the resulting sheets you are going to get the at what time or what day you are going to print it the results. Okay, then, and coming to the software, so in this mainly we are going to discuss about three topics over here. One is called weather report, and the second one spaces, and the third one is system report. So these are the three reports which we required to do our calculations. So before we are going to calculate these three, so first we have to create a project name. Okay, for what building or what project you are going to do this calculation, that project name we have to make it over here. So if you see here, initially it is showing as an untitled. So untitled means we are not assigned any project name to this project. Then what I am doing means just right click over here, and here we have option called properties. Go to the properties. So under the properties, here we have a project name. Okay, so what is the project name? That project name we have to mention over here. Let it be considered, I am going to take as an ACTMEP, Alpine Coach 3 MEP project. And the number, so the project number, what is the number? That number we can provide it. I am going to provide as 01, means it is a first project. And if you see here, automatically it is considering the date as well as the time. See, now the time is 2/6, and here it is taking as an 12/6, and here it is taking 12/1, because we open the software at 12/1. The same time it is considered over there. If you want to provide any contact number, we can provide the contact number and contact contact type and project. If you want to mention any notes regarding the project, you can mention the notes over here. And once it is done, give a OK. See, here it will be displayed. Okay, the project name is ACTMEP. Okay, and next coming to the weather report. So open the weather report over here, double click on the weather report. So here it is showing the weather report, and double click on this. See, normally in the manual calculations what we did, so first if you want any dry bulb temperatures, or if you want any wet bulb temperatures, or if you want any relative humidity, so based on the psychrometric chart and based on the ASHRAE standards what we have, we are going to find out and that values we consider it. But here, since it is in a software, we no need to calculate any psychrometric chart values or any other values. Only the thing is you have to select your city. So once you select the city, automatically the software it is going to take the entire dry bulb temperatures, wet bulb temperatures, all the values. So how we have to consider that values means, here we first one is region. Why they are asking the region means, this software is using the entire world, not only India, not only Dubai, or not only some other country, the entire world they are following this software. Okay, so that is the reason the entire world climate conditions will be preloaded into the software. Just only the thing is we have to select, so on which city, that depending on the project city we are going to consider over here. Okay, first the region. Under the region, ours is Asia. It's not a Canada or South America or Europe or Middle East. So I am going to consider the Asia. So under the Asia, the next one they are asking the location. The location means nothing but a country, that is India. Under the India, so for which city we are going to calculate, whether we have to calculate Ahmedabad, Bangalore, Calcutta, Chennai, Goa, Mumbai, Nagpur, Delhi and Trivandrum. So these are the some selected cities they provided over here. So just I am going to consider here, and the project is Bangalore. Okay, so once you select it, automatically show, see here we have a latitude, longitude, elevation, summer drivable temperature, summer condensate wet bulb temperature, daily range, winter drivable temperature and winter condensate wet bulb temperature. Okay, so each and everything defaultly we got it. For suppose, so here only the few cities they mention over here, but I required some other city which is not listed in this. So then what we have to do means, so just we have to go with a any one city, or you can mention the name over here. Let it be considered I am going with some example Hyderabad. So I consider as in a Hyderabad over here and here, but Hyderabad we are not getting any values because the Hyderabad values are not listed in this city. So which is they provided the HAP software. Then what we have to do, we have our designing information sheets, right? From there we can take a drivable temperature and wet bulb temperature. See, we can edit this also. So here you can provide that one. So by providing here, the software it is going to consider defaultly what the values we provided over here. Okay, and here I am going to consider Bangalore, and here these results it is going to take from 2001 HASHRAE handbook, from the handbook itself only. So this software is going to consider the values, and here normally we are going to consider that is from the entire year average values what we are getting from the HASHRAE handbook. But here while you are using the software, it is going to calculate the cooling calculation months, means for the entire year the software is going to calculate from January to till December. It is going to calculate for each and every day, each and every hour and each and every month it is going to calculate, and you are going to get the accurate results compared to your manual load calculations. So that is why nowadays all the people they are going with the instead of manual load calculation, they are going with a software load calculation. In the software load calculation, the main advantage is you are going to get the accurate results. Okay, so only these are the things which we are going to modify in our weather report. So apart from this, everything will be default. Don't change anything over here until unless you are getting any approval from your higher authorities or your client side. Until unless we are not going to change anything. And here I am going to give a OK. Done. And now if you want to see the results, right click on this and then print and view input data. So select this, you will get the entire reports. Okay, so in this, what are the reports you want, you can select it over here. The first one is design parameters, and the next one design temperature profiles and design temperature profile graph. If you want graph also, you can print the graph, and solar profile, and means that is nothing but a sun. From the sun how much heat we are getting from, I am going to consider from January to till December. Give a preview option, so it is automatically it is showing the entire results over here. See here we are getting the design weather parameters. The project name is ACTMEP. The duration 12 the time is 12:12. See, now the time is 12:12, so it is going to print it at 12:12 on today's date. And here, so this is our results. So the designing parameters, city name, location, latitude, longitude, elevation, everything we saw, and current data is from 2001 HASHRAE handbook. So designing cooling months from January to December, and here we are getting the designing results. Okay, so if you see the month from January to till December, all the directions, see here it is showing the north direction, north, east, northeast, east, northeast. See, normally when we are going to do the manual load calculation, so the maximum we are considering only 4 directions, which is east, west, north, south. But here in the software you are going to get the results for complete 360 degrees in 16 directions. So in every direction how much heat it is going to generate from the sun into the building, you are going to get the accurate results. So not only for 1 hour or not only for one day, you are going to get it for the entire year. Okay, so when you are going to get it for the entire year, obviously whatever the your resulting values, that will be very accurately you are going to get it over here. See, so till all the direction you are going to get it, and along with this, now this is only for months wise, January to till December month wise, and in the if you come down, so here they are giving is in a Bangalore India location hourly basis, midnight 12 o'clock to till 23, means total again 11 o'clock night 11 o'clock, total 24 hours on the January month. What is the dry bulb temperatures, what is the wet bulb temperatures, and February month dry bulb, wet bulb. So this is accurately you will get the values, and this is the temperature profile for Bangalore India. And the next one is solar fixtures and heat gain profiles. Solar fixtures means how much heat we are getting from the sun. Okay, if you observe in this, so here what will happen, see till midnight 12 o'clock to morning 6 o'clock, all the values are 0. Why? Because here that time we don't have any sun, we won't get any heat on that time, so that is why these all the values are 0. From 7 o'clock the heat generation will be start till evening 5 o'clock. Again after 5 o'clock it is going to be cool, so here also the values will be 0. So this much accurately you are going to get it by using software load calculations. And here see hourly basis, that is monthly basis, and this is the hourly basis you are going to get it. So this is how you are getting the report from your software load calculation. If you want to take this report in the manual load calculations, is very difficult, you won't get these kind of reports. Again if you want to create this report also, the number of hours will be increased, means again dedicatedly we have to keep a one person to print this all the reports, to prepare this all the reports is very difficult. So instead of that, so it is a easy way to create the report, results report. So once you create it, if you want to save this one, so here we have option called file, and here we have an option called save report as. So where you want to save it, we can save it from here. So you can create a one profile for this ACTMEP. So I am going to create it on the desktop with the name of ACTMEP results, ACTMEP project, open, and you can save it over here. So now it's saved. Okay, so next coming to the spaces. So now weather report is done, then we can go to the spaces report. Under the spaces report, new default space, select this. So this is one of the very important. So when we are going to do the load calculation, first we have to give the input to the softwares depending on our project application. So based on that we are going to provide all the inputs, then you will get the output result. So in that, the first one they are asking is general. General is nothing but in this we have to give the space information. The first they are asking the space name. So for this I am going to take a one project over here. So earlier which we discussed, so I am going to take the same school building, and here we have a, so let it be considered these are the 4 spaces. So let me consider for these 4 spaces the machine, the load calculation. I am going to take the room number 1. So this is the classroom number 1. So they are mentioning the name, the code number is G03. I am going to consider this one. Let it be mentioned over here, classroom G03. And the next they are asking the floor area. So this floor area you are going to get it from your architecture plan. So how to calculate the area? So for that we have to take a floor length and floor width, which we discussed last. So from here to here, and from here to here. So we can consider length as well as the width, but our requirement is, so here we are getting the values in terms of mm, but here the values they are asking in terms of feet square, okay, or feet. So now what we have to do, we have to convert from mm to feet. So how we have to convert means, in this AutoCAD we have one more command that is called dimension style. Under the dimension style, here we have option called modify. Go to the modify. Under the modify, so these are the primary units. Primary units is nothing but which is the default units, that is in mm, and here we have a one more option that is called alternative units. Select this alternative unit and display this alternative units, and here we have an option called multiplier for alternative units. So here we have to provide the value. So the value from mm to feet is 0.00333. So this is the value. So how this value you are going to get it means, this is we will discuss in your AutoCAD classes, which already we discussed this one. So just I am giving OK, set current and close. See, now you are getting both the values mm as well as a feet also. So the length is 36.53 and the width is 19.38. So just we can multiply, calculator, 36.53 into 19.38. So total 707.9. So let it be considered the total area is 708, and the next they are asking the average ceiling height. So if you want to know the what is the height means, whether first we need to check whether we have a false ceiling or not. If we have a false ceiling, up to false ceiling level we have to consider. See, we have a false ceiling over here and the height from the floor to the false ceiling is 9.91 feet. So that is we can consider as an approximately 10 feet of height. And here they are asking the building weight. Okay, so this building weight which we discussed this is you are getting from your floor plan. Under the floor plan we have that values over here. Let me open the floor plan. So these are the values. So right now we are calculating for the wall. So and here they are giving the mass. Mass is nothing but a wall weight. What is the wall weight over here? That is 80. So here we have to consider the wall weight, building weight is nothing but a 80. Okay, and here the next they are asking the OA ventilation requirements. OA is nothing but a outside air. This is nothing but a fresh air calculation. So how much fresh air we require into that room. So that is completely based on space used for. This is completely based on the application. And the thing is, here we need to select that room for what application we are using. Since it is in a classroom, so here we have to select this classroom over here. Under the classroom we have two types of classrooms over here. One is called classroom age of 5 to 8. Another one is classroom age of 9 plus. So this is, we have two classrooms. Now we have to ask the client, so this classroom they for what they are going to dedicate it. Okay, so whether this classroom for LKG or this classroom for 6th standard or 10th standard, that is we have to know. If you don't know that one, for the safer side, always we can go within a less value. Whenever it is going with a less value, automatically you are going to get the more fresh air. Okay, so here I am going to consider as a classroom age of 5 to 8. Then automatically you are going to get the OA requirement, that is for CFM per person and CFM per feet square. Okay, in your manual load calculation we will calculate these two based on ASHRAE 62.1 standards. CFM per person, how much fresh air we required, and CFM per feet square, how much fresh air we required. Okay, so this is the fixed values. Defaultly you are going to get it from your ASHRAE standard 62.1 and 2010, because before we are selecting 2010, right? So from the which is the updated values, so that updated values handbook, it is going to take the values over here. Okay, and the generalized done. And next coming to the internals. So in the internals, the first one is fixed type. Okay, so what is the fixed type means, first we have to know for what we are using this one, that is called overhead lighting. Okay, so in that room what type of lights they are using, first we have to know. So here they are giving us three types of lights. One is unvented light, vented light, and free hanging light. So unvented lights are nothing but which we are fixing into the wall, like a tube lights which we are fixing into the wall, that is called unvented. Vented lights are nothing but which we fix it to the ceiling, that is called vented. And free hanging lights are nothing but which we are hanging to the particular object. If you go to any Reliance or if you go to any cloth showroom, dedicatedly for which is the new arrivals, they are going to hang the light exactly on the product. So if you have any that type of lights, that is we will consider as a free hanging lights. And here since we have a false ceiling, so whenever we have a false ceiling, obviously the people there go with a vented lights 99%. If you have any queries, you can take a call with your electrical engineer. You can ask him whether they are going to fix any vented lights or unvented lights. So those people, they are giving the inputs to you. So here in our case, since we have a false ceiling nowadays, all the people whenever they are going to fix the false ceiling, the lights will be fixed to the false ceiling itself. I am going to consider as a vented light. And next, wattage. So the watts means the light, how many watts of lights we are using. So if you know the watts, then you can select the watts. If you don't know the watts, then you can go with the watt per feet square. Okay, so the watt per feet square, this is we called as an LPD, light power density. So that is we are going to get it from your HVAC material. So this is your LPD values, lightning power densities. In this we have to select the application. So our application is classroom lecture training. And what is the value they provided here? 1.4 watt per feet square. So now this value we have to provide over here, that is 1.4. And here they are asking the ballast multiplier. So what is the ballast multiplier? Already we discussed in our manual load calculation. So here I am entering the constant value 1.25. Okay, and here they given the schedule. So what is this schedule means? These lights per day, how many hours we are going to usage. So that values, that hours we have to consider over here. Since it is in a classroom, so I am going to consider the lights are turn on at morning 9 o'clock, because 9 a.m. the students will come to the classroom and they are leaving at 4 p.m. The same time I am going to consider over here. And here if you go to the next hourly profile, total they given the 8 profiles over here. In this we will consider any one profile. I am going to consider profile number 1. Under this, see here they are giving us, okay, so midnight 12 o'clock we are not going to turn on the lights. So like this you can turn off it at what times we are not using the lights. Only for usage purpose it will consider. So I am going to consider at 9 o'clock to till evening 4 o'clock, that is nothing but a 16 here, and from 7 o'clock also I am going to turn off the lights. So while you consider like this, you are going to get the accurate results for your power. See here they given given over here, and the next one is give a OK. So and here we have one more called assignments. So what is the assignments means? See this profile 1, per week how many days we are using. For example, this 9 to 5, this is only we are using Monday to Saturday. So Monday to Saturday only the classes will be there. Sunday will be holiday. So the Sunday no need to consider over here. Now what I'll do, from Monday to Saturday I am going to select all these columns from January to December, or for example in May month we have any holidays, correct? So I am not considering the May month because students have any holidays on May month. So I am considering only from January to April month May month I am going to not using, and July to till December again the classes will be there. Sorry, June to December. So June to December I am considering profile number 1, and here we can take a profile number 2. I am going to turn off all because that is representing of we are not using anything on that time, so I am going to turn off it. So this is nothing but we are providing this to profile number 2 whenever we have a holidays. So the holiday time we can provide this one. So schedule assignment, see profile 2 empty, right? So I am whenever the Sundays as well as the holidays time I am going to take a profile number 2, means it is not going to calculate any load on that time. So this is how accurately we can assign. And here also May month is completely 0 2. Okay, give it. So we created the schedule, and the next they're asking the task light. Task lighting is nothing but a focus lights above which is the 100 watts lights. That lights we called as a task light. So if you take any auditorium, in the auditoriums we have projectors. If you take any pubs, there we have disco lights and all. So means these lights we are getting a more watts. So whenever we have a more wattage light, so from the light we are getting the more heat. So that is why they are giving separated task lights. Since it is in a classroom, so here we don't have any task light. If you consider any lab over there, in the lab we have a projector. So the projector we consider, but since here we don't have, we no need to consider any any task lighting over here. If you have a task lighting, same procedure. Either you can go with the watt per feet square, or else you can go with the watts. Again the schedule, how many hours we are using, for that we have to create the schedule over here. Okay, and next electrical equipments. So the electrical equipment mostly we are going to prefer with watts, and these values you are getting from your electrical engineer. If they are not providing as a general values, we have to consider. So since it is in a classroom, let it be considered what the electrical equipments will be there. Since if it is in an international school, for each and every classroom we have one water filter. In the water filter we have hot water, cold water and normal water. So if whenever we are going to take a hot and cold, definitely in there we have a compressor. Let it be, we can consider some 300 watts the water filter. We have a fans over there. In the classroom, always they are not going to use the AC. Some hours they are going to use the AC, some hours they are going to use the fan. So let it be considered, each room we have a 5 fans. Each fan let it be 100 watts, total 500, and water filter 300, total 800 watts. And apart from that, no, we don't have any other things. Let it be considered, I am going to consider here 800 watts. So when we are going to use these fans as well as this water filter, means definitely whenever the students will be there, that time we are using this one. Clear? So here again no need to create a separate schedule, because already we created the schedule number 1, right? That is 9 to 4. Whenever you are going to take the same timings for other, if it is in 9 to 4, then you can follow the same schedule. If any time changes will be there, then again you have to create your new one more profile. Until unless you can follow the same schedule, I am going to follow the schedule number 1. Okay, and next occupancy. In the classroom total how many people are there? For that we require furniture layout. See here 1 2 3 4 1 2 3 4, total 8. 1 2 3 4 5 6 7 8. 8 8 is 64 plus 1. Total 65 members are there. So here I am going to consider 65. And next here they are asking the activity level. Once you are giving the activity level, then automatically BTU per hour per person, which is the sensible heat as well as the latent heat, automatically you will get it over here. So I am going to take it here, the activity level. Since the people they are going to sitting and listening the classes and taking the notes, it's not like a seated at rest. It's not a office work. It is not like a sanitary work, heavy work, dancing or athletics. So since we can consider that sitting and doing something, so we can consider as a medium work. So when you select it, automatically sensible heat as well as the latent heat, we got it. Again the schedule is same because 94 only the people will be there in the classroom. Okay, and next miscellaneous load. So what is this miscellaneous load? Is nothing but a, apart from your small fans and all, wherever we have a big missions like robotics or like in the automobile companies or in the pharmaceutical vaccine manufacturing units, so in the places what will happen, so we have a big missions. Whenever you are going to calculate the load calculation for the entire area of the industry, so then along with the people, along with the lights and along with the electrical equipment, we have to calculate the machinery load also, because from the each machine you are getting a lot of heat, so for that also we need to consider over there. So what is the miscellaneous load? So this miscellaneous load you are getting from your client side. So what are the missions will be there for each and every mission? What is the sensible heat as well as latent heat? If the client is not providing, who is the design engineer, he has to go to the site and he have to verify the missions, total how many missions are there. For each and every mission they have a label, mission property label. In that they are mentioning what is the temperature. So the temperature we are going to, sorry, that is not that is the mission BTU level they are mentioning on that. That BTU levels we have to take a note and we have to mention on this. Since it is in a classroom, so here we don't have any machinery, so no need to consider any miscellaneous load over here. Okay, so the internals are finished over here, and next coming to the wall, windows and door. Okay, so here we are going to consider the wall, especially they mentioned as an exposure wall which is exposed to sunlight, so that is we need to consider over here. So since we discussed last time what is wall, here in this room we are going to do the load calculations now. So for this total in this room we have only one wall, because this is the only one which is exposed to sunlight. The other three, these are the partitions, this is non-exposed to sunlight. Okay, so which is exposed to sunlight, so that is we consider as a wall. Now we have to know this wall is on what direction. So that is normally the architects they have provided over here the direction of the building. If they not provided over here, let me consider on our this basis, north, south, east, west. So let it consider, I am going to consider this is in a north direction. So this is a north direction over here. Here go and select a north, and now here they are asking the wall gross area. So this wall gross area we have to calculate now. So for that we know the length of the wall which is a 36.53, and if you want the area of the wall we have to consider the height, length into height of the wall. The height you are going to get it from elevation. Height is nothing but we are not going to consider up to the false ceiling level. So the height which is exposed to sunlight, that is we have to consider up to the slab level. So this is 9.9, let it be considered 10 feet, and this is 3.38, total 13.38 feet of height. So 13.38 into 36 into 13.38, total 481.68, let it be considered 482. So the total wall gross area is 482, and they are asking the number of windows. So here in this plan the number of windows, total how many windows are there? Here one window and here one window, total 2 windows are there. Here the window quantity 2, and here they are giving us a window 2 quantity. So what is this window 2 quantity means? In some buildings for some projects what will happen, sometimes for one wall we are getting a different sizes of window or different shape of window. Since it is in a school building, so you can observe here all the windows are same sizes and same shapes, so no need to consider window number 2. If any other size of window, then you have to separate windows we have to consider. Since this one and this one both are same, so no need to consider any window quantity. Okay, and coming to the door quantity, so here in this project we don't have any door. So here we don't have any door. Door is nothing but here we have a door, but this is the door placing on a partition wall. So whenever the door which is exposed to sunlight area, then only we will consider the door. Until unless we are not going to consider the core. If this door will be here, then we have to consider. So then we have to calculate the number of doors over here. But since here not exposed to sunlight, no need to consider. So here we don't have any doors. Okay, and like that, sometimes what will happen, if the instead of one wall you have a two walls exposed to sunlight, then in other direction also we have to do the same procedure again. For suppose this wall is exposed to sunlight means, then you have to take the width and height, then you will get the total area. So that is we have to consider in other direction. So here, since in our plan we have only one wall, so we consider only one wall over here. And now here they are asking the wall property. So select this one, and here we have to mention the wall property. So the property wall is nothing but a, here we have to take the U value, like in our, how we are going to calculate for our manual load calculation. So in the same way here also we have to provide the load value, U value over here. But if I want to change, it is not changing over here. I'm trying to change this one, the U value is not changing. So how we have to get this U value means from your architectural plan. So this is my architectural plan, and here they give the external wall section, the entire property. So these values we have to mention over here. Okay, and now here the first one is they are giving us a inside surface resistance. Before this, here they are asking the outside surface color. Outside surface color is nothing but outside what type of paint we are using, whether we are using a light paint, medium paint or dark paint. This is nothing but a color. So why they are giving this one means, if you are taking a light and medium, so that heat absorption will be less compared to your dark. Okay, since here we don't know what color they are using over there, because the architecture people, they didn't mention anything. Always we will go with a high, which is a dark. Then obviously, even though if they are considering tomorrow is in dark also, whatever the cooling load we are providing to the room, that is more sufficient. So I am going to consider always dark. And here we can write the wall assembly name, what type of wall it is. I am going to consider this is an external wall. And here absorbability is nothing but a 90%, that is nothing but a 0.9. And here now we have to provide the wall materials. What are the materials they are using over here? They are giving us a inside surface resistance, outside surface resistance, and gypsum board, what type of material and what is the thickness. So the thickness and everything we have to provide here. And this is one option, or else we have one more option over here. See here, they are giving us an outside surface resistance and inside surface resistance and material. The same text we can mention on this. See here, the first one inside surface resistance, and here they are providing the value R. So the R value already we have, the the inside surface resistance R value. See the R value we have to provide, that is 0.68. So here the inside surface resistance, the R value we have to change this one, 0.68. And the next one is here 0.5 inch plaster, cement and sand. If you want to mention the description, we can mention 0.5 inch plaster, cement and sand. So if you want to write the description, you can write the description like this, and the R value we can provide over here. So the R value is 0.10. So here 0.100, and the same next 10-inch concrete block. So 10-inch concrete block. So polystyrene. So you can mention the description. So the R value 10.163. So here 10.163. So now whenever you are changing, see here the U value is changing over here. And the next one is again points plaster, cement and sand. Here 0.5-inch cement and sand, and here the value is 0.100. 0.100, and here not required this one because the outside surface already is there. If you want to delete this one, see, right click on this, and here we have an option called remove. Select the remove option, and we can remove the one more row, and here we have outside surface resistance. This value we have to consider now. So the outside surface resistance value is 0.250. So 0.250. So now you got the U value, right? What is the U value? 0.089, and now you can cross check with your U value which the architect people they provided. So that is also 0.089. So this is how we have to give the property, wall property. Once it is done, give a OK. Then it is going to, these values will be loaded into the software now. Done. And next coming to the window one. So now here we have to provide the window name. Okay, what type of window it is. So I am going to consider this as a glass window. And here they are asking the height of the window and width of the window. So we require a height and width. So height of the window is 3.94, and you can take as a width of the window 5.75. So we can provide this value 3.94, 5.75. 3.94 and 5.75. This is the feet. We had to remember that one. The values we have to given in feet. And here they are given the U value, which is the default U value. If you know the U value, we can change the U value. If you don't have the U value, don't change this U value until unless the client is going to give the value. Okay, or else you can consider as a default U value over here, and the shaded coefficient also. So overall shaded coefficient, that is nothing but a window outside above. If you have any shades, the shade coefficient value we have to consider. And here they are asking the glass details. So here we have an option called detailed input. If you are given this detailed input, these glass details will be activated. Okay, for that time we have to ask the glass people what type of glass they are going to install in the window. Okay, whether some people they are using a clear glass, some people they are using a layer glass, some people they are using a high thick glass. So what type of glass it is, so that glass we have to consider over here. Okay, since here we have a different sizes and different type of glasses, you can select what type of that. If you don't have any any input from your client side, then you can turn off, then it is considered as a default. So no need to change anything. Default it is going to consider what type of glass and all. Okay, and give a OK. So then it is going to consider. So since we are not taking any shades over there, because for these buildings they are not providing any shade values. Shades are nothing but a outside. So they are giving the left side overheading, means above side, or right side. If you have any kind of shade will be fall on our window or fall on our building, that shades we have to consider over here. Nowadays for the building we are not going to consider any kind of shades until and unless specifically they are going to provide the values. We are not going to consider over here, because if you want to consider, compulsory they have to provide these values. Height above the window. So what is the height after above the window? What are the window height will be there, which is the 3.94. Above that the shade, what is the height will be there. So that height we have to consider here. Okay, and since we are not considering any shades, I am not going to use it this one. So if you have a door, for suppose if you have a door over here, the door values we have to provide over here. What type of door we are using, whether it is in a glass door or wooden door. So the name we have to give a entire gross area of the door. Okay, if the door is 7 feet by 4 feet, 7 fours are 28. So the 28 we have to consider over here. And what is the door U value? And in the door, if you have any glass, the glass area we have to provide over here, and glass U value and everything coefficient, shade coefficient of the glass. This is we have to get it from your glass people, from the glass people. So since here we don't have any door, no need to consider. So this is your wall, window and doors. And next come to the roof and sky. So whether if we have any roof or not, that is we have to check. For that, first we have to know for which floor we are calculating. So for this room we are calculating. So here they are giving is a reflected ceiling for ground floor. Above the ground, if you have any building, then that is not a roof. See here we have a first floor. So here we don't have any roof because above this floor we have a first floor. For first floor we have a roof because which is exposed to sunlight. So that is we consider as a roof. Since here we don't have any roof, only we have a ceiling and false ceilings will be there. So no need to consider any roof properties over here. Okay, when you are going to calculate for this classroom which is in the first floor, then compulsory we have to go with a roof because for above the first floor we don't have any other floor. This is the last floor. Then we have to consider the roof values over here. So let it be considered. In this case I am going to explain. I am going to consider, let it be imagine. So this is the only one floor building. We don't have a first floor. We have only one floor building. This is I am going to explain only for your understanding. So I am going to consider here we have a roof. Then how we are going to take the values. So here we have to consider the H. Since here this building is a horizontal building, so we have a horizontal roof. So you can go to your elevation plan. See here we have a roof of horizontal. See this is a horizontal roof for this, and for the ground floor this is in a ceiling which is in a horizontal. Okay, and see here I am going to consider this is a horizontal roof. So here we have to consider the H, horizontal. Then automatically the roof area it is going to consider. No need to consider separately. Okay, and now here we have to give again roof properties. Select the roof. Again we have to give the input from your architecture values. See here we have a roof values. Total how many rows are there? 1, 2, 3, 4, 5, 6, 7, 8. Total 8 are there. And here 1, 2, 3, 4, 5 are there. But we require 8. Then what I'll do? I am going to inserting 3 more. 1, 2 and 3. Total 8. Now here we have to provide the R values. So the R values you are getting from your architectural layout. And these are the R values. These R values we have to provide over there. So first one is 0.125. So here 0.125. 0.131. The next one is 0.131. Next one 0.100. 0.100. 12.549. 1.443. 0.936. 0.100. 0.460. 0.460. So you got a 0.063, and now you check with your this value. This is also, see here they given 0.063. So whatever you get it, that is correct, and you can write the description. That is only description. That description is not affected on your load. The load is completely based on your R value. R is nothing but your resistance value. So based on your resistance, you are getting your U value, that is BTU per R per feet square for foreign heat. Give it OK. So these values will be loaded. Again here they are giving one more, that is skylight. What is the skylight means? If you see in your building, so here we have one open to above, means in one area for the lighting purpose they are going to install the glass in the roof section. So whenever you are having this kind of roof, okay, or this kind of glass, then we have to consider this skylight quantity. So this skylight quantity, when we have to consider, means whenever you are going to do the load calculation for this lobby area, that time we have to consider this consideration, okay, because the skylight will be under your lobby area but it is not in your classroom, so no need to consider over here the skylight. So whenever you have a skylight, the skylight height, skylight width and depth we have to consider. Since we don't have here, so the no need to consider any skylight. Okay, so that skylight value, how many skylight quantities will be there, that skylight will be provided over here. But since in our classroom we don't have any skylight, no need to consider it. Okay, next coming to the infiltration. So the infiltration is nothing but a leakage. So leakage from the door and leakage from your window. Whenever the leakages will be there, the leakage value we have to consider. As per the standard, for each window leakage value will be 25% leakage will be there. So that is we consider as 0.25 for each window. So now we need to check total how many windows are here in this classroom. Total how many windows are here? Total we have a 2 windows. 2 windows are nothing but each one 0.25, total 2 windows 0.5. So automatically you will get the CFM and CFM per feet square. Okay, that is for cooling, heating and energy. Both these three values are constant based on your window. Okay, and the infiltration occurs when it is going to occur only when the fan off or all hours means whether in air conditioning running time as well as your fan running time, whatever it might be, out of 24 hours every hour we are going to consider, that is all hours. If it is only when the fan is going to rotate, so that time also we need to consider this one. Okay, that is called your infiltration. So now infiltration is done. Next come to the flows. So here in the flows they are giving a 4 type of flows over here. Floor above conditioned space, floor above unconditioned space, slab floor on grid, slab floor below grid. So here we have a 4 types. So first we need to understand what is conditioned space, what is unconditioned space, on grid and below grid. So for this we have to go to your elevation plan. So if you see here, this is one classroom and this is one classroom. Okay, so the first one is they are giving us a floor on conditioned space. So floor on conditioned space means, for suppose when you are going to calculate the load calculation for this classroom, this is the floor. If the below floor also air conditioning, from this floor you won't get any heat to this floor. So then this floor we consider as a conditioned space. Unconditioned space means for this room if you are not providing any air conditioning, since here existing some heat, this heat will be through this floor, it is going to this room. That is called unconditioned space. Now on grid and below grid. On grid is nothing but see here whenever we have a false ceiling like this, then this is we consider as an on grid, means from here we have an on grid. Below grid is nothing but a down. So here we don't have any grid, since it is in a foundation, below that we have an earth. This is we called as in a below grid. Okay, since right now we are going to do the calculation for your ground floor. Ground floor is nothing but a, below this we don't have any grid, this is we consider as an unconditioned space. Why? Because from the earth, definitely some amount of heat will be generating into the room, because definitely earth will be heated when the sun will be there. So obviously some amount of heat will be coming over here. But when you are doing the load calculation for your first floor, then no need to consider any heat over there, because this already existing cooling will be there. No need to consider any cooling or any heat generation over here. But here we have to consider this is in a unconditioned floor, because from definitely from earth we are getting some amount of heat. Okay, so here I am going to take as a floor above unconditioned space. If you take a conditioned space, 0, because there is no heat transpiration, so the 0 heat generation. Once you click your below unconditioned space, so then obviously again it is going to take your maximum temperature, minimum temperature and everything. Here only the thing is we need to change your U value. So this U value you are getting from your architecture layout. So here we have a typical floor. The typical floor U value is 0.358. So here I am going to take a 0.358. So this value we have to provide. And next, partitions. So total how many partitions will be there, so that all the partitions we need to consider over here. Now going to your plan. So total here maximum we have a 3 partitions. This is the partition number 1, partition number 2 and partition number 3. So mainly here we have to take only non-AC partitions. We are not going to consider any AC partition. So here I am going to consider only non-AC partition. Non-AC partition is nothing but since this is the classroom, here also we are providing AC. So from this partition we won't get any heat. So this partition we call as an AC partition, means 0 heat generation. If the client is required to provide a corridor area also air conditioning, centralized air conditioning, so from here also you won't get any heat. This is also 0, no need to consider. Here we have a storeroom. So definitely for the storerooms no one is going to provide any air conditioning. So compulsory from the storeroom some amount of heat will be generating into the classroom. So then this is we call as a non-AC partition. Again we have to calculate for this, for non-AC partition. So first we have to calculate the partition area. For that we require a width which is 19.38 and height we consider up to false ceiling level height. So since it is in a partition level, up to false ceiling only it will be there. That is 10 feet height, 9.9 we can consider as a 10. So the 10 into 19.38. So 10 into 19.38, that is nothing but a 193.8. So the total area of the area is 193, and we have to consider it is in a wall partition, and the U value we have to provide over here. The U value you are getting from your this one partition U value is 0.487. This is the U value. So 0.487. Here we can consider 0.487. Okay, and then give a OK. Sorry, I forgot to change the glass window. Yeah, done. So this is how we have to create the spaces. Now we created only one space, which is a classroom 03. Next we have to classroom 04. Again the same procedure. Take a room area and the room width. See, if you see here 36.53, 36.53, 19.38, 19.38. So these same classrooms both are same. Then again no need to calculate any again no need to take any one more new spaces over here, because already we created a one space which is a classroom number 0.38, and for this we have to do the duplicate. Okay, because all the inputs are same, so no need to do any modifications. Just we can create the duplicate. Double click, right click, and here we will get an option called duplicate. Create a duplicate, and here we can change the classroom number 04, and all the values will be same. That's it. This is one more advantages they have. Again no need to calculate from the scratch. So once you create one space, if other space will be the same dimensions and same thing, you can create a duplicate. Okay, and here we will try to create for one more room, that is the room number Z19. What I'll do for this, we are going to calculate one more value, one more space creation, so that you will get an idea. Now here the external wall is, instead of north direction we have a south direction, but the materials, U values, everything will be same, and the area of the room is 30.47 into 20.21. so here we will consider 30.47 into 20.21, so total 615. So 616.7 is there, no? 616 I am going to consider. Again I am going to create a one more duplicate, and here Z09. So this is I am making as an editing now. So I have created a duplicate. After the creating duplicate, I am editing according to the room values. Then that is also classroom, and this is we have to change 616 average area and classrooms, internal heats all are same, no need to change anything, and only the furniture layout, in the furniture layout we have to change it. So here see, this is the furniture layout. In the furniture layout, the number of people 8, 1, 2, 3, 4, 5, 6, 7. 7 8s are 7 8s are 54. Let it be 56. 56 plus 1, total 57 members. Now here 57. This is how we have to edit it. Wall, instead of north we will consider as in a south direction now. South, and here we have to give the wall area. So the wall area, because other values will be everything same, because the material will be same in the entire project. So now 30.47 into 13. Already we know the height is 13, which is external. 30.47 into 396.11. So here we'll consider this is 396. And number of windows, how many windows are here? Since here also we have 2 windows, so no need to modify the windows over here. Done. Wall, external wall section, glass same, roof again same, infiltration same because 2, floor and condition space, and we have a total how many partitions, non-AC partitions, that is we need to consider. Office room AC partition, classroom AC partition, corridor AC. So here no need to consider any partitions, so make it as an area 0, because all are AC partitions, you won't get any heat from the partition 0. Give a OK. So this is how we have to edit the space. Once your space creations are done like this, you have to create for the entire your floor. So in the floor, total how many spaces are there in the entire floor? For all the floors we have to create in this way. Only the thing is, the main difficulty, it's not difficulty, it will take time to create for one space, the first space. Then for other spaces it is easy, either you can create a duplicate or else you can create a editing, duplicate editing also you can do it. Okay, so the next one is, in this we have to go to the systems, and if you want to see the reports over here, right click on any one space, view input data. See whatever we given, floor area, average ceiling height, building height, complete, what are the inputs you given, so it is taken over here. And next come to the system, new default system. Okay, so in this, the main thing is, the first we have to take a general. In this first they give the air system name. So what type of system we are going to install here. As we discussed in the previous videos, in the video number 3, sorry, video number 4, in that we are going to discuss how many types of systems we have. We have a 3 types of systems. One is DX system, BRF system, and chiller system. So any one system we are going to select it over here. So I am going to select over here as some DX system. So when we have to select a DX system, and when we are going to select a BRF system, and when we are going to select a chiller system, in further classes I will explain very clearly that one, and why, what is the reason, what is the advantages and what is the disadvantages of each and every system. We will discuss on that. Okay, and here given the system name DX system. Next, equipment type. So what type of equipment we are going to select it here. So here we have different types of equipment: packaged rooftop unit, packaged vertical unit, split air handling unit, this is AHU, chilled water air handling unit, and terminal units. If you want to select any type of rooftop unit or vertical units, you can select it from over here. Since here I am selecting a DX system, so here we have an DX means split air handling unit. So I want to provide only one mission to the entire 3 rooms. I am going to select this air handling unit, and here they are asking the air system type. What type of system we are going to use it? CAV is nothing but a constant air volume single zone, and the constant air volume dual duct. So mostly in India 99% the people they are going with a single zone. Okay, so in a Gulf they are going with a multiple zones, because there we have a district cooling plants. So there we are going within a dual ducted system, but here in India we are going within a single zone, and here the number of zones, that is a 1. Okay, why it is going to consider number of zones 1 means, since I am going to select only one mission over here, which is a dedicated mission, so that is why it is taking for the entire building as in a zone 1. If you are doing any other terminal units, in this again you will get a one more drop down. In this, what type of system you want, we can select it over here, that is called split DX fan coil unit. If you want to install any fan coil units, you can go with the fan coil units over here, then you can give a number of zones over there. Okay, so here what is the number of zone is nothing but a combination of spaces we called as in a zone. Okay, so combination of spaces are nothing but a, if you go to your spaces, in the spaces we created a 3 over here, 3 spaces we created. For these 3 rooms, if you are providing only one mission, then we consider as in only one zone. If 3 rooms, if you are providing a separate missions, which is a 003 separate mission, 04 separate mission, and 09 separate mission, then we have a 3 zones and 3 spaces. Okay, like that we have to consider. So I am going to take here the separate rooms, separate missions, then we will see how we will get it. I am going to the system, new default system. I am going to take this as a DX fan coil, and here I am going to take a terminal units under the terminal fan coil unit, and number of zones 3 zones. Once description is done, then go to the zone components. Whatever spaces you created in the space column, so all the spaces will be displayed over here. Under the zone 1, I am going to add G1 room, because when you are adding from spaces to the zone, automatically the software is going to calculate the load calculation. Next, zone 2, 04 I am adding in the zone 2, and for mission 3, that is nothing but a zone 3, I am adding the third mission. This is how we have to allocate it. If you want only one mission, for one mission if you want to add these 3 missions, then you have to create only zone 1, then add these all the missions into the zone 1. Okay, so since here we are going to take a separate missions, I am going to take a zone 1 separate mission, zone 2 separate mission, and zone 3 also separate mission. Once you are allocating the zones, then we have to go to your thermostat. So how many hours the machine has to run. See here they are giving us a cooling as well as the heating, which is the occupation. So whenever the people are there, then it has to give the cooling of 75 degrees Fahrenheit, which is the human comfort level temperature for the heating time as well as the cooling time. And here we have an option called thermostat schedule. Select this thermostat schedule, and here we can give a schedule time of 9 to 4. That time only the people will be there. Profile number 1. In this we have an unoccupied, occupying. So whenever the people are there, that is we call as an occupied. Whenever the people are not there, that is an unoccupied. So the people, when it will be there, since it is in a classroom, 9 o'clock the people will be there. So till 9 o'clock we are going to consider the room is in an unoccupied time. So 9 to 16, 4 o'clock, again 5 o'clock we have to take a unoccupied time over here. Unoccupied, done, and give a OK. And here the other values don't disturb anything, so that is clear. And next, coming to the sizing data. Under the sizing data, here we have to provide the safety factors. In the manual calculation, when you are going to do the sensible heat and latent heat as well as the heat gain, in the same way how we are providing the safety factors, here also we have to provide the safety factor. The safety factor value is, for the sensible it is 10% of safety, for latent 5% of safety, and for heating 5% of safety. Once it is done, give a OK. Sorry. And here at last, equipment type. If you want to edit any equipment, create the edit type of equipment. So this edit type of equipment will be only we are going to change it when from the design engineer, from the project engineer, if they are giving any specifically input data, then only we are going to change it. Until and unless we are not going to change anything over here. And give a OK. And give a OK. So if you want to know the total TR of the 3 rooms, right click, print and view simulation results. So what are the things you require? Just select it and give a preview. Design, not simulation, design results. Sizing, summary, what are the zone load, space load. So separate loads if you want to know, and hourly basis also if you want to know. For each and every hour how much cooling is required in that room, for each and every room we can select it and give a preview. It is going to calculate it. See here you are getting the DX fan coil, number of zones 3 zones, total floor area. So the complete information you got it over here. And here you get the CFM of each zone. See zone number 1, 2, 3. Designing airflow, CFM is, see here we got it. CFM 1858. If you want TR, 1 TR equal to 400 CFM, as we discussed in the last class, previous classes. I given the unit conversions. 1 TR equal to 400 CFM. Now for the zone number 1, means space classroom number 1, here we are getting the total CFM of 1857. If you want in terms of TR, divided by 400, 1 TR equal to 400 CFM. Then the total machine capacity for first classroom, which is the Z04, 4.6, Z05, because both are same equal classrooms, right? We can make a duplicated that one. That is we are getting the exact, and that is also 4.6. And the classroom 3, the area will be less compared to the both the classrooms. See, these are the areas 708 and 708, and classroom number 3, which is the 616. So for this we got is a 1763 divided by 400. Here you will get a 4.4 TR machine. So this is how you will get it, the separate machine loads. Okay, and here you not only you will get the cooling load, if you want heating load also you will get the heating. See here, this is the cooling results from the doors how much heat we are getting, from the roof how much heat we are getting, from the wall how much heat we are getting, all the BTUs we are getting, total zone load. See here they are giving the total condensating, total this is the load in terms of BTU, British thermal unit, 126,580. If you want to do the conversion, we know into the terms of TR. So what is the total BTU? 126,580 divided by 12,000. 1 TR equal to 12,000 BTU. You will get it. So this is the load for all 3 rooms. So the separate total load for the 3 rooms is 10.5 TR. So for the same buildings, if you for the same rooms, if you want heating, the heating load we got it over here. So based on this we are going to select the heater coil, and based on this we are going to calculate your evaporator coil, that is called your cooling load capacity. See the entire results you are going to get it. So zone number 1, how much BTU cooling load, how much heating load. Zone number 2, cooling load, heating load, and zone number 3, cooling load, heating load. Like this you will get it. Okay, so based on this, the company people, they are going to order the machines to the site. The same machines we are going to install in your buildings. Classroom number 3, classroom number 1, classroom number 2, and classroom number 3. So like this, before we are going to calculate the system, we are going to do the entire space calculation for the entire floor and entire building. Once your space creations are done, then we have to come to your system calculation. In the system calculation you will get the report. Again you can save this report on your computer desktop. That is how we are going to create the system. Okay, so this is your HAP calculations. So you people try to do the assignment. So in the assignment I am going to give a one project. Once you do the assignment, so you will get a hands-on experience as well as you are getting the confidence level how to do it. Okay, if you have any queries, please comment in the comment box. So I am going to give a reply for that, or else one day I am going to conduct a doubt sections. In the doubt sections I can clear all your doubts. Okay, thank you.